But first of all, what we're going to do is we're going to just randomly pick a point on this parabola and call it 8, 4. So just pretend that that's the numbers that are there. And we're going to think about a parabola. Do you remember that if you had a negative outside your parabola, it made the parabola go down? We're going to find out now, if you take a whole function and put a negative outside, it does that same idea of reflecting over the x-axis, a vertical reflection. So if I draw that, that would be down there. If I think about the point 8, 4, if you flip this down, does it make sense that that point is going to change to 8, 4? If you flipped it down, you're doing something vertical. Anything vertical affects your y values, because your y values go up and down. And so all that's happened here is my y value gets multiplied by -1, and the whole graph is getting flipped over the x-axis. If we have a negative on the inside of our function, inside is always going to affect your x values. Inside is always something horizontal. When the x's were liars and you had a number inside, it moved it left and right. So now, this negative here would take that original graph and flip it horizontally. This point 8, 4 would go not to this side, but all the way over to this side, and it would now be -8, 4. So labeling those points helps us see, with a specific example, what's happening to a point. And what I'd like you to do in the space beside, we're going to have two things that we're going to write down. You can write this one first. If the negative is outside, and sometimes it's there, and sometimes they put it with the y, that is a vertical reflection over the x-axis. And what happened when we went from the red graph to the blue graph? That multiplies the y values by a -1. Here, I'll scroll it up so you can see it better. And then you can also write down what happens when it is inside. Let's go to example 1. They give us the graph of g of x. we want to sketch the image graph after reflection in the y-axis. So the first thing I'm going to do here, I'm going to highlight this part here that says reflection in the y-axis. And right above it, with reflections, it seems like the exam has about 4 different ways of asking, 3 or 4 different ways of asking the exact same thing, just using different words. So first of all, I'm going to show you all the different ways we can say reflection in the y-axis. Here's my y-axis. Reflection in the y-axis moves things left and right, flips it left and right. So sometimes this shows up as a horizontal reflection. Okay? Sometimes they don't say y-axis. The equation of the y-axis is x equals 0. So sometimes they'll say over the line x equals 0. And sometimes I've seen reflection on the y-axis or in the y-axis. Little words change like that. Any one of these is a horizontal reflection. Sometimes, and since this is g of x, they'll just give the equation for it. Could you graph y of g of negative x? That negative is inside with the x. Anything inside with the x is horizontal. So we have one new concept that can be asked in 4 different ways. This just makes it more complicated than it should be, but it's unfortunate. They like to do that, ask the same thing just in a slightly different way, so you have to know 4 ways of doing the same question. Now that we have that, well, this point here, do you see that it's 3 away from your y-axis? So if I reflected it over, it'll be 3 away on the other side. This point is 1 away from my y-axis, so reflecting it over will be 1 away on the other side. This point is 3 away, so 1, 2, 3 there. And this one's 1, 2, 3, 4, 5. So if I flip it over, 1, 2, 3, 4, 5. Connect the dots. And there's my graph's reflection. If I wanted to look at particulars, and I'll do this just with 1 point, this point is at negative 3, 1. The negative with the x would multiply the x value by a negative, and you notice that this point is positive 3, 1. The only thing that's changed is that x coordinate. The x coordinate has been multiplied by a negative 1. Graphically, that does a whole flip. Algebraically, it just multiplies every single x value by a negative 1. So then, domain and range, the original one's domain has the smallest value of -3 and the biggest value of 5. My original range had a smallest value of -2 and the biggest value of +2. On my blue graph, now my smallest value is -5 and my biggest value is +3. And on my blue graph, my smallest y value is -2, and my biggest y value is +2. And sometimes the exam will ask you questions like, explain why the range doesn't change. Why did the range not change? You would have to explain in words. Well, reflecting in the y-axis is a horizontal reflection and affects only the x values. Only the x values are multiplied by a -1. And since only the x values are changing, it makes sense that my range, which are my y values, don't change. Can you see how multiplying by the -1 affected the domain? See how the 5 became the -5 and 3 became +3? So circle questions 3 and 13.